Today we're covering section 6.2, solving systems by substitution. So today we're going to learn a new method to solve a system of equations. Remember, when solving a system of equations, one of three things can happen. We can have intersecting lines that give us one solution. We can have parallel lines that give us no solution. Or we can have the same line, which gives us infinitely many solutions. We saw these yesterday in our lesson about solving by graphing. Today, though, we'll be using algebra to solve the system of equations. So for intersecting lines, we will get one ordered pair answer. But for parallel lines and for the same line, similar to when you're solving an equation and you get no solution or infinitely many solutions, we're going to see something similar where we lose the variable and we either end up with a false statement, so we have parallel lines and no solution, or we end up with a true statement, infinitely many solutions because we have the same line. So there's a lot going on here with the rules, but I would like you to take time to write these down, because when you go back later and we know all of our methods, it's helpful to have the directions here on how to solve by substitution. So the first thing we want to do is look at either equation and try to find a variable that has a coefficient of 1, because this is going to make it the easiest. You're going to solve that equation for that variable. So one of the two equations in the system will have to be solved for either x or y. Then you're going to substitute the resulting expression into the other equation and solve for the variable. Excuse me. Once you have one of the variables solved, then you're going to plug that answer back into either of the original equations to solve for the second variable. And then again, we will write our answer as an ordered pair. So again, today's method is going to require us to use algebra. So the first system, we have y equals 2x minus 4 and 2x minus 2y equals 8. The first step said to look for one of the equations where the coefficient in front of the variable is a 1 and solve for that variable. Well, you'll see in our first equation, it's already solved for y. And sometimes this happens with substitution where one of the equations is already set up. What we're going to do is we're going to take the expression that's equal to y and we're going to plug it in for y in the equation down below. Again, if y equals 2x minus 4, then I should be able to plug 2x minus 4 in for y of the other equation. And this is what we get. 2x minus 2 times the quantity of 2x minus 4. Notice I'm plugging that in for y. And it equals 8. Now we need to solve this equation. Distributing the negative 2 through the parentheses gives me 4x plus 8. Be careful there, watch your signs. 2x minus 4x is negative 2x. Now I'm going to subtract 8 from both sides. We get negative 2x equals 0, dividing by negative 2. X equals 0. So the ordered pair where these two lines intersect has a 0 in the x-coordinate. Now, in order to find the y-coordinate, you can plug 0 in either equation. The first equation, the one that's solved for y, is going to be the easiest place to put it. So in order to figure out what y equals, I'm going to take 2 times 0 and then subtract 4. 0 minus 4 is negative 4, so we get y equals negative 4. So the ordered pair is 0, negative 4. Number 2, we have 2x plus y equals 7 and 3x minus y equals 8. In the first equation, you can see that the y variable has a coefficient of 1. And even more importantly, it's a positive one. So this first equation is going to be easier to solve for y than the second equation because we won't have to divide by that negative at the end. So for the first equation, I'm just going to subtract 2x to both sides. Again, I'm trying to get the y by itself. That's going to give me y equals negative 2x plus 7. Now I've got the first equation solved for y, so I'm going to take this part of the expression, and I'm going to plug it in for y in the second equation. What this does is I'm writing y in terms of x. Y equals negative 2x plus 7, so I can take that and plug it in for the y in the other equation, and now I have an equation, watch your signs here on this one, that just contains x's. And because this equation now just contains x's, I can pretty easily solve for x. Remember, this is like having a negative 1 out in front, so I'm going to distribute that through the parentheses. So 3x plus 2x minus 7 equals 8. I'm going to solve this equation. And we get x equals 3. So the x-coordinate of the ordered pair where these two lines will intersect is at 3, something. Again, the easiest place to plug this 3 back into, because I need to plug it back into one of the equations and solve for y, so I can figure out what the y-coordinate is. The easiest spot is going to be where you've solved that equation for y. That's the easiest place to put it. So I'm plugging 3 in for x to figure out what the y is. And you can see here that y equals 1. So these two lines would intersect at 3, 1. Number 3, again, that first equation has a positive 1y, so I'm going to go ahead and solve that equation for y. You will see examples where we solve for x. Remember, this is the first step, because now that I know what y equals, I can plug that in to the second equation. Now again, I have an equation that only has one variable, so I can solve for x. So this is 2x plus 3x minus 4 we're going to add 4 to both sides. Dividing by 5, we get x equals 2. I'm going to plug 2 back into that first equation there. Y equals negative 3 times 2 plus 4. So y equals negative 2. And number 4, you'll see in the first equation, they both have, x and y both have a coefficient of 1. I'm going to go ahead and solve this equation for x, just so you can kind of see it done the other way. We've solved the first 3 for y. And again, the reason why it's much easier to solve an equation with a coefficient of 1 for that variable is because if I tried to solve this bottom equation for x or y, I would have to divide at some point by that coefficient, and then you end up with fractions, and then things just get really messy. So it's much easier to do it this way. I'm going to go ahead and subtract y from both sides here. That's going to give me x equals negative y. I don't have to write the plus 0, but now that since x equals negative y, I'm going to plug this part of the expression this time in for x, because it's what x equals. X equals negative y, so I can replace the x with a negative y. So that's what we're going to do. So replacing the x with a negative y, this gives me negative 5y and we get y equals 1. So this time we've found the y coordinate first. Now we're going to plug that back in to figure out what x equals. If x equals negative y and y is 1, then x equals negative 1. There wasn't a whole lot to do there, not anything to solve. So these lines would intersect at negative 1, 1. Okay, first equation, x and y both have coefficients. In the second equation, x has a coefficient and y does not. So again, we're going to make it easy on ourselves by subtracting 3x to the other side and solving the second equation for y. And now remember, this negative 3x plus 4, it's what y equals. So I need to substitute it in for the y in the first equation. So plugging negative 3x plus 4 in for y, and now I need to distribute the negative 2 through. Add 8 to both sides, and I'm going to combine my like terms at the same time. So 12x equals 12, and x equals 1. I'm going to use this equation down here that I have solved for y to plug in my x. Negative 3 times 1 is negative 3, and negative 3 plus 4 is 1. So we get 1, 1. You can check your answers. I should have mentioned this earlier, but it is possible to check your answers. You can just take that ordered pair and plug it back into both equations. Remember from yesterday's lesson when I would ask you if a particular ordered pair was a solution to the system, and you were able to verify by plugging the ordered pair in to see if it solved both equations. And if it did, which this ordered pair should, it should solve both of those equations, then we knew we had the right answer. Okay, in example 6, the first equation is the only one that has a variable with a 1 in front of it. It is a negative 1. We're going to have to deal with that at some point where it's not just super easy, so let's go ahead and do it here. Solving this for y still, because I'd rather divide by a negative than have to divide by a 2. So even if the coefficients aren't positive ones, a negative 1 is the next best thing. So I get negative y equals negative 2x plus 7. Now I have to divide everything by negative 1. Notice I won't get fractions this way. So y equals 2x plus, minus 7. This is what y equals, so we're going to plug it in right there. So I have 4x minus 2 times the quantity of 2x minus 7, and it equals 14. Notice I'm writing the entire equation, just substituting this piece in for y. Now you're going to see here when we combine like terms that these are going to cancel each other out, and I get 14 equals 14. So here is one of our special cases. Remember from this earlier slide that when I lose the variable, my options are going to be parallel lines, which are no solutions, or the same line, which is going to be infinitely many solutions. Well, in this example, I have 14 equals 14. That is a true statement. And so these two equations, when graphed, would actually be the exact same line. So our answer here is infinitely many solutions. That's because every ordered pair on one line is also on the other line. So infinitely many solutions. In class, I'll check your notes and we will work on worksheet 6-2.